Hello, everyone, and welcome back for System of Inequalities Example 2. I know the suspense has been crazy for you waiting for the second video, but here it is. We're going to go ahead and graph this system that we see right here. You'll notice both of them are in standard form, so if you were paying attention to the first video, the first thing I do is get this in something that's easier to graph. I prefer slope-intercept form. I mean, it's graphable and standard, but it's just something that I do. So let's go ahead and do that. We'll do this one off to the right. So I like to rewrite this. 4x plus 3y is greater than 6. That 3 is a little suspect there, so we'll make it a little better. All right, so I'm going to go ahead and get y by itself. Usually it's the same kind of process. I'm going to first move the x term. It's a positive, so the opposite would be subtracting it on both sides. That leaves me with a positive 3y because that sign's going to stay. I'm not going to write it though. And then when I do this, it doesn't really matter what order I write them as long as they keep their sign. So I'm going to do the negative 4x first and then follow that by the plus 6. And then, we want to get rid of whatever coefficient's in front of y, in this case a 3. Opposite of multiplying by 3 is dividing by 3. Make sure all terms get divided by that 3. And then we're going to go ahead and get y is greater than negative 4/3 x plus 2. And again, we want that x after that fraction. So that's going to be what we graph for this problem. I'm going ahead and going to copy and paste it here just so I have it kind of where the old one is. All right, so we're going to do the same process. I like to just do this for both of them, right? You could do one and then graph it and do the other. It's really up to you, right? Math can be done a couple different ways, and it's personal preference. I prefer to just get steps done and then move on to a different kind of step. All right, so x minus 3y less than or equal to negative 9. Same thing. I get rid of that x term. It's positive, so to move it, I'm going to subtract it so that they turn to 0 and kind of cancel each other out. I'm going to be left with a negative 3y, right? Don't forget about that sign there. We're going to keep that. And then on this side, x is negative. I'm going to put that first. So negative keeps its sign. And 9 stays minus 9 as well. Okay, now, same thing. I need to divide. Now, this is where things get slightly different than the last equation. I'm dividing by a negative 3, right? Since I'm choosing to divide by a negative, right? Doesn't really matter what's already there. Like this one doesn't matter that it's negative, and this one and all that. It's because I'm choosing to divide by a negative, I need to then switch the inequality, right? Flip it to the other one. So instead of being a less than, it's now going to become a greater than. The or equal to doesn't change. And then a negative x divided by a negative 3 is 1/3 x. The two negatives cancel, and there's kind of a 1 in front of that x that we don't see, so we're going to put that in the numerator. And the same thing with the negative 9 divided by negative 3. Those two negatives cancel, and 9 divided by 3 is 3. Right? And you can see the important part here is that my sign switched or flipped when I divided by a negative. Anytime you multiply or divide an inequality by a negative, you got to switch that sign. If you forget to do that, the only thing that would be different is you shade the wrong side. So if you find that mistake and you want to fix it, just go ahead and erase your shading and shade the opposite side of that line. So that's the good news. Bad news is if you're using paper and pencil, erasing an entire side of shading is not much fun. All right, so let's take a look at this. We're going to graph them individually. Remember, first you do the one, then you do the other as if the other one didn't exist. First thing I do is look at the y-intercept. So I'm going to go ahead and get that negative or positive 2 as my first point on the y-axis, so positive 2. And then I'm going to follow the slope, which is negative 4/3. All right, so negative 4/3. So negative means I go down and to the right. 1, 2, 3, 4. 1, 2, 3. And I'm going to keep doing that until I run out of room. 1, 2, 3, 4. 1, 2, 3. And 1, 2, 3, 4, 1, 2, 3. Oh, look at that. I got room for a last one. Don't get lazy on this. You want to do as many points as possible. I can't go any more down and to the right, so I can switch both directions and go up and to the left. 1, 2, 3, 4. 1, 2, 3. Good. All right, and you're going to want to graph that. Now, this is a dashed line, so I'll try to be as neat as possible. If it's a solid line, it makes it straight for me, so that's always nice. In this case, it doesn't, so bear with me on how sloppy the line is. Okay, there we go. Now, I need to shade, right? That's the first step, is graphing it as if it were a line. Second step is shading. I always test 0, 0 as my point. And you can see 0, 0 is not on the line, right? You can't test any points on that line. You're just going to get two sides that are equal to each other, which won't really help you. So I'm going to test 0, 0, and 0 greater than 0 plus 2, and I won't skip through that. So if you don't know where that 0 came from, right, basically I plug in a 0 for x, and anything times 0 is just 0, and 0 plus 2 is just 2. So here we end up with 0 is greater than 2, which is not true, right? That is not true. So 0, 0 is not a solution. Right, so nothing on that side can be a solution. That means everything on the other side has to be a solution. So I'm going to shade the opposite side of the point I checked. Right, so when you're checking a point, if it's true, shade that whole side. If it's false, shade the other side. Right, and we're going to go ahead and shade this as nice as I can. If you want to fast forward through this, go ahead. But I know it's very satisfying to see that perfect shade. Kind of missed that bottom there because I didn't have it in screen, and I can't really lift it and do it a second time, but no big deal. All right, let's do the next one. So we already made our equation slope-intercept form. I copy and pasted it here. So here we have the plus 3, so the y-intercept is going to be the first thing I graph, and you can see that we have that right here. And then I'm going to follow the slope of 1/3, right, 1/3. So that means I'm going to go up 1, right 3, and I'm going to keep doing that until I run out of room. And that also means I'm going to go down 1, left 3. So do that till I run out of room, and we're good to go. Right? Then this one's a solid line, so I'm going to do that better. Right? Get my solid line as far as I can get it, and put little arrows on it. And again, I can test 0, 0 because it doesn't fall on the line, so that's going to be the one I plug in just to make my life easier. I'll do it over here where I have a little more room. 0 greater than or equal to 1/3 times 0 plus 3. It's an ugly 0. That turns to 0 and cancels, so we get, well, it doesn't really cancel, it just kind of doesn't affect the plus 3. 0 is greater than 3. That's definitely not true. So I'm not going to shade where 0, 0 is. I'm going to shade the other side, which is right here. So I'm going to go ahead and shade this as nice as I can. I'm not going to spend too much time on it. I know you're probably already sick of listening to me talk, and I kind of just put in filler words while I'm shading. All right, so now that we have all of the inequalities shaded, and if you didn't watch the first example, when I do the blue one, obviously it was the only one there, no big deal. When I'm graphing that red line and shading, I pretend the blue one doesn't exist, right? When you're doing a system of inequalities, you graph them all individually like they were their own inequality. And then once you have them all graphed, the difference is with a system is you need to find the overlap. All right, so the first thing I do is I find the intersection of the two lines, or 3 or 4, doesn't really matter. Wherever all of the inequalities intersect, in this case there's only 2, I put a point there. And in this case, since the blue line is dashed, that point is actually not part of our solution. It's kind of the border for our solution, but that point itself would not be a solution to the system. Now, however, this red line that I'm kind of coloring over in purple, that is part of our solution, any point on that line, except for the one where they intersect. However, the blue line is not. So the blue line's still a border, so I'm going to go ahead and make it purple. If you were on paper, you would just make that line darker. That's going to be not part of our solution because it's dashed. That's not part of it, but the shading is. And then we're going to shade all the inside And any point that falls in this inside area is a solution to our system because it makes both inequalities true. Whether you plug it into the red one or you plug it into the blue one, it'll hold that inequality true. So since it's a solution for all the inequalities, it's a solution for the entire system. And that's all you have.